Well, welcome back to school, everybody. I miss you all very much. We're going to see what we can do here, and hopefully we'll get through this together. This is for Trig, and we're going to start chapter 5. So this is 5-1, and these are the ever infamous Trig identities. This whole chapter is about identities. I love it. We're going to start out with some things that you already know, and these are called the reciprocal identities. So reciprocal identities. And these are the ones that, we have a sine of theta. Anytime you have a sine of theta, you can replace it with 1 over cosecant theta. Anytime, those are reciprocals of each other, so we can also come over here and say that the cosecant of theta is equal to 1 over the sine of theta. So what this means is that anytime I see sine of theta and I need it in a different form, I can replace it with this. This is one identity. There'll be some other ones that we do, but this is one thing that you can do. You're probably asking, why do I need to know these kinds of things? Well, these are just kind of the fundamentals that you're going to have to know how to do and know how to replace things with and substitute so that you can solve equations, and we'll get there later in the chapter. But right now, it's just seeing if we can do some small identities and making one side of an equation look like another side of equation, or using what we have and manipulating that to get to something that we want. So here's our sine and cosecant is our first two. Our next pair would be cosine of theta is equal to 1 over the secant of theta. And since those are reciprocals, we could also say that the secant of theta is equal to 1 over cosine of theta. So there's two sets. We have one more, which is tangent theta. Tangent is equal to 1 over the cotangent of theta. And we have cotangent theta is equal to 1 over tangent theta. So there's your 6 reciprocal identities. And we'll do some problems with just those, and then I'll give you some other identities and give you some problems with just those. So we're going to take it slow, and hopefully we can all get through this together. So there they are. Write them down. Have them next to you whenever you're starting to work your problems. Those are the reciprocal identities, and let me give you one more small set. These are the quotient identities. So tangent theta is equal to sine of theta over cosine theta, and cotangent theta is equal to cosine of theta over sine of theta, which I think you already knew those from working on problems before. So this means that anytime we have tangent of theta, tangent of anything, tangent x, tangent beta, whatever, you can replace it with sine of theta over cosine of theta as long as all of these match. So that's same thing that you can do with the cotangent of theta. You can replace it with cosine of theta over sine of theta, or if you have that rational equation or whatever, you can replace cosine of theta over sine of theta with cotangent of theta. So they work hand in hand. Okay, I'm going to have to erase these because my board is not very big. So have those next to you somewhere. If you need them again, just go back and look at this video. So let's work a problem with that. Let's say, here's our first example. Let's say that the cosecant of theta is equal to 7 over 4, and we want to find the sine of theta. And this is the only information that we're given. We want to find the sine of theta. And we want to do this without knowing what theta is. We don't know what that angle is. We can do that because we have an identity that is for sine, and it involves the cosecant. So you use that identity and just set up your equation, you know that the sine of theta is equal to 1 over cosecant theta. So we just plug that identity in there. And now what I can do is I can go through and substitute this in here for the cosecant of theta. So I'm going to do that. I'm just going to erase this. I know that sine of theta is equal to 1 over cosecant theta, and cosecant theta happens to be 7 over 4. So now all I have to do is do this math problem, which is a complex fraction. So you can multiply it out if you want. 1 over 1 times this reciprocal is 4 over 7. And we get 4/7. So there's your answer. That's how easy it is. Okay, let's do another one that's a little bit more complicated. Let's say we know that the cotangent of theta is equal to 2 over 5 square root of 5. And we're told that the sine of theta is equal to square root of 5 over 3. And we want to find the cosine of theta. We want to know what the cosine is without knowing what theta is. So what you do is you have to figure out which identity you need, and that's the hardest part. Whenever we get a lot more of these, you're going to have a whole page of identities, and I'll share that with you once we get to that point. But right now you just have a few of them. The hardest part for people is figuring out which identity do I need to use. So I know I have cotangent, I have sine, I want cosine. So is there any way to replace this cotangent or write cotangent in terms of sine and cosine? And there is. We know that we can use the identity of cotangent of theta is the same as cosine of theta over sine of theta. So I write that identity down, and then I just go through and I replace everything, substitute things that I know, and then see if I have enough information that I can solve for the unknown. So cotangent of theta is equal to this. So I'm just going to rewrite that. Cotangent is 2 over 5 square root of 5. That's equal to the cosine of theta, which is my variable basically. I don't know what that is, so I'm going to leave it cosine of theta, over the sine of theta. Sine of theta is going to go down here, and we know what the sine of theta is. It's the square root of 5 over 3. So now basically you have a one-step equation here, and you need to solve for cosine of theta. So if I want to solve for cosine of theta, I need to get rid of this denominator. I'm just going to multiply both sides by the square root of 5 over 3. Multiply this by the square root of 5 over 3. These cancel. So I'm left with cosine of theta on this side. And over here, if I cancel those out, I end up with 2 in the numerator over 3 times 5, which is 15. So the cosine of theta is 2 over 15, and that's it. That's your answer. That's what you were looking for. We can find out these trig values, and we don't even have to figure out what theta is. So there's your answer. Okay, so those are, that first example was with the reciprocal identities. Second example is with the quotient identities. And now let's get what we call our Pythagorean identities. So Pythagorean identities one that you will use all the time, and you'll memorize this one really, really quickly, is that the sine squared theta plus cosine squared theta is equal to 1. They have to be squared. So it's kind of like, we call them Pythagorean identities because it's kind of like a squared plus b squared equals c squared. So if I square 1, I still get 1. So sine squared plus cosine squared equals 1. That's an identity. Anytime you see a 1, you can replace it with sine squared plus cosine squared. Or anytime you see sine squared plus cosine squared theta, you can replace it with 1. And that's going to save you a lot of work later on whenever we get into some really big problems. The second one is tangent squared theta plus 1 is equal to the secant squared theta. So again, anytime you're stuck and you've got a problem, you've got tangent squared theta plus 1, you can replace it with secant squared theta. Just kind of reduces it to one term instead of two terms. And then the last one is cotangent squared plus 1 is equal to cosecant squared. So those are your three Pythagorean identities. And you can move these things around. So I'll just use this last one here so I don't have to go back up here and erase everything. But if I wanted cotangent squared instead of cosecant squared by itself, I can subtract 1. So I can say cotangent squared theta equals cosecant squared theta minus 1. All I did was move that term to the other side and subtracted it. So there's another potential identity. You can do the same thing with both of these. You could solve this for sine squared. You could solve it for cosine squared. You could solve this one for tangent squared, or you could solve it for 1. So once you get one identity, you have a few more because you can move things from side to side. So those are the identities you want to keep handy. And let me show you how to work a problem dealing with these. One thing that we have to go back and hopefully just refresh your memory a little bit. We need to know when things are positive, when they're negative, which trig functions. So if you go back and remember, every trig function is positive in the first quadrant. Sine is the only one that's positive in the second quadrant. Tangent is positive here in the third, and then cosine is positive in the fourth quadrant. So do you remember that little guy I told you about, Allison Tancos? Kind of keep that stuck in your head because we're going to need to know, based on the information, whether we've got to have theta in the right quadrant, so we'll need to know which sign it's supposed to have. So Allison Tancos, and that's when they're positive. So that means tangent and cosine are negative here. Sine and cosine are negative here. Sine and tangent are negative here. But everything is positive in that first quadrant. Okay, let's do an example. So this is example 3. Let's say that we are told tangent of theta is equal to -8. We're told that the sine of theta is greater than 0. And we want to find sine of theta and cosine of theta. So they're telling me that this is positive. The sine is positive and the tangent is negative. So you kind of need to figure out, and it's really not too hard, to figure out where the angle is located, just so that we know what signs to put on sine and cosine. We know sine is positive, so whatever answer we get here will be positive. But let's think about that. Our tangent is negative. Tangent is negative here and here. But we know that sine is positive. Well, sine is only positive here and here. So you can see that we've got this scenario right here. We know theta is up here in the second quadrant somewhere. That just means when I find cosine, I need to make sure I put a negative sign in front of it because it's in the second quadrant. So we know that cosine is going to be a negative answer. Okay, so now what we need to do is go back and use one of our identities. Tangent of theta. If you're given tangent of theta, let's use tangent squared theta plus 1 is equal to secant squared theta. So we can just plug this in here. Tangent squared, that's the same as -8 squared, because they told me that tangent theta is -8, so I put that in here, and we square it. Plus 1 is equal to secant squared theta. You may be saying, well, why did you choose this one? We don't even want secant. Well, if we know secant, we also know cosine, because we can just flip it upside down. Remember, the reciprocals. So it will get me to my answer. So we'll just say this is 1 over cosine squared theta. So if I solve this, this is 64 plus 1, so this is 65, is equal to, let me go back and just leave this as secant squared theta for a minute. So this is secant squared theta, and now I want secant instead of secant squared, so we're just going to take the square root of both sides. So the square root of 65 is equal to secant of theta. So now that we have the secant, this is our numerical answer. We can just find the reciprocal of it and we'll have cosine. And we know that we want our cosine to be negative. So the reciprocal of this is 1 over the square root of 65. We're going to make it negative. If you want to leave your answer like that, I would accept that. We know that it's not rationalized, but if we rationalize it, all you have to do is multiply the numerator and denominator by the square root of 65. So that'll be negative square root of 65 over 65. So there's our cosine. This is the cosine. So there's one of our answers. And then we need to find the sine. So let's erase all this, so I have no room. We know that cosine of theta is equal to negative square root of 65 over 65. And the tangent is negative 8, and we want sine. So now I'm going to go back and use, you can use any identity that will get you to the answer. One of the quotient identities comes to my head first because sine and cosine will get me a tangent. So I could say tangent of theta is equal to sine of theta over cosine theta. And then you just replace everything that you know and solve for your unknown or whatever's left that you didn't substitute for. So tangent theta is negative 8. Sine of theta we don't know, so we're just going to leave it. And then cosine of theta is negative square root of 65 over 65. So now we've got that same scenario that we had earlier. We're just going to multiply both sides by negative square root of 65 over 65. Put negative 8 over 1. So our sine of theta is going to equal a negative times a negative is a positive, which we know we want to get a positive because it tells us sine is greater than 0, and we're in the second quadrant. This will just be 8 square root of 65 over 65. So there we have the sine and the cosine, and that's what we were asked to find. I know this is kind of feels rushed, but again, you've got this video now. You can go back and watch it as many times as you want. Stop it when you want. Save your questions. I'm going to have a Zoom conference probably Wednesday or Thursday, and you can ask me questions. My Snapchat is just Andy Sutton. If you want to look me up on Snapchat, you can ask me a question. You can email me questions. You can Snapchat me, whatever. Or you can just write your questions down and we'll have a Zoom conference on, well, I'll let you know what date that'll be in my lesson plans. But don't hesitate to contact me somehow. It's going to be tough, so we'll work through this together. All right, so I'll give you some problems and we'll see what you can do with them. Have fun.